ante kada.
Yes,
So
sir.
these two wheels
Yes,
in
sir.
the rotational dynamics, what we are talking about is, we're talking about the condition in which a body is rotating and also translating. So when you sit in your car, the wheels in which you are sitting the car, the wheels of the car will be rotating, and these two wheels which have been connected by this rod are not rotating, but it is making these two wheels to move in the front direction. That means there is a translatory motion and also a rotatory motion, isn't it?
Yes, sir.
Isn't it? Like say the fan, ceiling of a fan. So the ceiling of a fan, the axis is always your fixed beta. Axis of rotation is always a fixed, and the blade connected to this one are been rotating. So this is called what? A pure rotation. It is called as of what?
Yes,
A
sir.
pure
Only rotation.
rotation. The axis is at rest. If axis is also moving from one point to another point or translating from one point to another point, such type of a motion is called as of your rotational dynamics. Such type of a motion is called as
Dynamics.
of
Yes.
what? Rotational dynamics part of relation. I hope you got an idea right now there, isn't it? So what do you mean by rotational motion,
Yes,
beta?
sir.
When the axis of your rotation, when the axis of your rotation moves, isn't it? Then the motion of the body
Yes.
is a combined transliteration and as well as of your rotational motion. So that is called as of your rotational dynamics. That means if the axis of rotation is not only moving, translating, but it is also rotating, Such type of a motion is called as
Both
of your,
translation and rotation.
yeah, both translational motion. Example
Rotational
is Iron
dynamics.
Man, a machine in which it is moving in all 360 degrees, translating, moving, rotating. Everything is happening in that one. Such type of a motion is called as of what? Rotational dynamics part of relation.
Dynamics.
Okay.
Yes.
Okay. So in the rotational dynamics, we divide the motion into two parts beta. One is about your translation motion. Another one is your rotation motion. Translation motion about your center of mass. So we write the velocity of this one as VCM, and rotation motion about an axis through center of mass. You know that when a particle is moving, VCM can be written as of, in the circular motion we have written this one as, but V is equals to R into your omega. This is a condition for what? A pure rolling. This is a condition for what? A pure
Yes,
rolling.
sir.
So motion is been divided into two parts. One is your translational motion, VCM, and another one is a rotational motion about an axis through the center of mass part of relation. And both of them are VCM. This is because of the translation and this is because of your rotation. Okay, no?
Yes, sir. Yes, sir.
Now see, that means the kinetic energy of this rigid body, whatever I'm writing, the kinetic energy of a rigid body that has both the translational and rotational motion can be expressed as K is equals to translational kinetic energy plus rotational kinetic energy. Translation is in your kinematics, in the work energy, we have written this one as what? Half into M into your VCM square. And kinetic
Yes,
energy
sir.
due to rotation is written as half into ICM into your
I
omega square.
into omega.
Isn't it?
Yes, sir.
So it is a combination of translatory and rotatory. So K is equals to half into M into VCM square plus half into ICM into your omega square part of a relation. Is it clear?
Yes, sir. Yes, sir.
See this one. We are talking about rolling motion without slipping. That means there is no slipping at all. There is no slipping. So what is the condition for no slipping? We'll try to do. Now see here, it is a combination of pure translatory and pure rotatory. When you add both of this one, what are you doing? You are adding a pure translatory and you are adding a pure rotational.
Pure
Then
rotation.
that is called as of your rolling motion. That is called as of what? Rolling motion. I hope you got a clarity. Pure translational
Yes, sir.
plus pure rotation. If two of them are vectors, kabatti, when I add both of them, whatever the motion I'm getting, the resultant motion, that resultant motion, we are calling it as of what? A rolling motion. Is it clear?
Yes, sir. Yes, sir.
Isn't it? Now see, in pure translation motion, what is happening is each and every particle of the translatory motion is moving always in the front direction only, and that is like with VCM. Okay, like say for example, when you're moving on a road, your hand, your leg, your head, your body, your chest, your whatever the part is being present in your body, each and every part of your body is moving with the same velocity, isn't it? Or else it is
Yes, sir.
happening like that, you are moving in the front direction, so your leg is moving in the opposite, or your hand is moving in opposite, your head is moving in one direction. Is that happening something like that? No, no. When you are going
No,
from
sir.
one point to another point, the total system's velocity is always in which direction, beta? Front direction. So in the same way, in the
Yes, sir.
pure translatory motion, like say if we are having 10,000 of your particles, each and every particle anywhere it might be in the translatory motion, for that one the velocity is always in the front direction. Like say if I'm taking at point A, the velocity will be in the front direction, that is VCM. At point B, if I'm taking right now at highest position, the velocity is of your VCM. At point C, this is a point C, the velocity is at your center of from the point is in the forward direction. And at point D, at this circumference, that is also moving in the front direction with VCM. The center of this body is also moving with your VCM. This particle is also moving with your VCM. This particle is also moving with VCM. This particle is moving with ACM. This particle, each and every particle which has been present in this one is moving in the front direction only. Is that point clear?
Yes, sir.
Okay, na? So in pure translatory motion, what is happening, beta? Each and every particle present in the body is moving in the front direction, part of relation. Okay, na? Something like this. Like say if
Yes,
this
sir.
one was if your pure translatory motion, if your particle is here, it is moving in the front direction, VCM. If the particle is here, the velocity of this one is VCM. If the particle is at the center, this one is your VCM. If the particle is here, that is also your VCM. If the particle is here, it will be your VCM. If the particle is here, this will be your VCM. If the particle is here, this will be your VCM. So each and every particle
Every
is moving in the front direction only. That is called as of what? A pure translatory motion. It is called as of a pure translatory motion. Is it clear?
translatory motion.
Okay. Now చూడండి,
Yes, sir.
it is added చూడు, ఇక్కడ plus symbol I have written here. This one is been added with what beta? A pure rotation. Pure rotation means, remember the ceiling of a fan. The ceiling of the fan is always
Yes,
at
sir.
fixed only, no? Isn't it? And the body is
Yes, sir.
rotating with angular velocity omega. You know that when the particle is moving in the circular path, when you add it to a pure rotation, when I add you a pure rotation, if there is a particle here A, this is your particle here B, this is your particle C, and this is your particle D. Now tell me, thinking twice. So this one was your A, this one was your B, this one was C, and this one was of your D. Now at the center, this axis is fixed kada. So what is VCM at the center beta for this one? 0 for pure rotation.
Yes, sir.
So see the ceiling of a fan. Is it rotating? Kaadu kada. It is always fixed,
No, sir.
isn't it? So only the blades which have been connected, or the circular part which has been connected,
Only
that is
those will
rotating.
run.
The axis will be at rest. So velocity of center of mass of a pure rotatory motion is how much for me? Pure rotatory motion is fixed. That means at the center, the velocity of VCM
0.
will. Now, what about your like say omega? If this is moving with an angular velocity like this, at this point A, the velocity will be equal to how much weight? R omega in this direction. Ante kada, if the party is moving like
Yes,
this.
sir.
If the particle is at B, the velocity is for this one in this direction, R into omega in the positive x-axis.
Yes, sir.
And at
So
point
just
C, what
moving
is
towards
happening
this
to the
point.
velocity? In the upward direction of this one. So this one is your R
Ah,
omega in the upward direction. So now coming from
yes, sir.
C, A to C, C to B, and B to D. What is the direction of this one? This one is in this direction. This is your R omega. This is also your VCM. This is also your VCM. Everything is VCM. This one is also your VCM, and this one is also your VCM part of relation. So each and every particle which has been rotating in the circular path is having a pure rotation motion. In the pure rotation, R omega will be the condition, but center of mass, it will be 0. Is that point clear?
Yes, sir.
Isn't it? Now see, that's what happening in this one. So in this one, whatever the particles have been present, in the direction you need to write the velocity. Like say at point A, it is R omega in this direction, and point B, R omega in this direction, point C, R omega in the upward direction, and point D, R omega in this direction. And this is also a rigid body. It also has n number of particles. A particle direction అవుతుందో ఆ particle direction you need to take. Like say if the particle is at the center అన్నాడు అనుకో ఇక్కడ, ఇప్పుడు ఇక్కడ నుంచి ఇక్కడ రేడియస్ R అయితే ఇక్కడ నుంచి ఇక్కడ రేడియస్ ఎంత అవుతుంది? R/2.
Ah, yes, sir.
అవునా కదా? So this is R beta from here
Yes,
to
sir.
here,
Half of it.
from center to this one, it is half. If still it is in half, means
Yes, sir.
somewhere here R/4, like that
R
you
by
can write
4.
this.
Yes, sir.
Okay.
Yes,
So
sir.
I hope you got right now what is a pure translatory and pure rotatory. In pure translatory motion,
Yes, sir.
each and every particle is having the same VCM, whereas in the pure rotation, the velocity is R omega, and that depends upon the direction of your rotation. Okay, now
Yes,
you
sir.
add both of them now.
Yes, sir.
This If you add this both beta, now see at point A and this point A, both of them are point A only. Na? This is also your point A.
Yes, sir.
Point A, you add it here right now. So at this point, if I'm
Opposite.
writing, so it is a pure translatory plus pure rotation is equals to pure rolling. So this will become for me how much? VCM minus R omega.
Yes, sir.
Velocity at point A means what? VCM minus R omega. Now at highest position,
Yes,
B
sir.
got VCM is in this direction and this R omega is in the front direction. So if you add both of them, VCM
VCM
plus,
plus R omega.
okay. Now at this position, point
Yes.
C, VCM is in this direction, R omega is in opposite direction. So both of them are perpendicular,
Yes, sir.
isn't it? Like say, if the
Yes,
point
sir.
C, if I'm picking, if I'm adding, for point C due to the translatory motion, this is your VCM. Due to rotatory motion, this is your R omega. These are two
R
vectors
omega. Yes.
kabatti the resultant ikkada vastundi. So this will be the resultant
Yes,
of
sir.
your VC, which is making an angle of theta. So if I need to angle, write the angle there, tan theta is equals to, this is a vertical component, that is R omega by your VCM. What is VCM value? I told you it is only VCM. So if it is also VCM will get cancelled. That will be equal to 1. So that is
1.
tan theta. Tan theta is equals to 190. Theta will become how much?
45.
45. Got it? Now at point
Yes,
DC,
sir.
at point D, you add it. At point D, this is your VCM in the front direction. This is your point of your D. Now at point D, for this one, it is in the downward direction. This is your R omega in the downward direction. So resultant will be in this direction. So this is the velocity of your D, making an angle of your theta like this. Got an idea?
Yes, sir.
Got an idea, isn't it? So now what is happening is, so you
Yes.
can add both of this one beta and write the whatever the resultant velocity we are getting, that motion is called as a what beta? A pure rolling motion. That is
Rolling.
called as a what? A pure rolling. So for no slipping, what is the condition beta? Now see here, for no slipping, velocity of the wheel at that point where it is in contact with the surface. Now in pure rolling, where it is in contact with the surface beta? At point A, isn't it? Like say the
Yes,
wheel
sir.
of the car,
Yes.
the wheel of the car, isn't it? It is in contact with the
Yes,
ground
sir.
at this point only now. So for no slipping, velocity of the wheel at that point where it is in contact with the surface should be equal to how much? 0.
0.
Okay, so velocity of wheel at
Yes,
point
sir.
A, at this point A beta, velocity of the wheel at your point A will be equal to how much for me? VCM minus R omega. VCM
Yes, sir.
minus R omega is equals to 0. That means VCM is how much? VCM is equals to R into omega. So this is the condition for rolling without slipping. That is a condition for rolling without slipping part of relation. Is it
Flipping.
clear?
Yes, sir.
Isn't it? So VCM is equals to R omega. So condition for rolling without slipping is what for me? So VCM is equals to R into your omega. Is it clear?
Yes, sir.
Is it clear? So what is the condition for rolling without slipping? Velocity of your center of mass. This VCM is now equal to how much beta? R omega. So now
R
if
omega
VCM is
dot
equal to
D.
R omega, now for the pure rolling at point B, what will be the velocity beta? You write here also R omega, R omega. It will become 2 times of R omega,
Yes, sir. 2 R omega.
isn't it? Or else it will become 2 times
Yes,
of
sir.
VCM.
Yes,
And
sir.
then now at point B, at this center, this is VCM and this is 0. So here only we will be getting VCM. And
Yes, sir.
now at point
Yes,
A,
sir.
if this VCM and this R omega are same, now what I am getting at point A? 0 kada.
What, sir? Once again.
At point A, VCM and R omega
Yes,
are
sir.
same kada.
Yes, sir.
No, we got already VCM is how much better? R
Then
omega
0.
only. No? Now you take R omega here
Yes, sir.
and this one is also R omega. Both equal and opposite kada. So what is happening? They'll get
Yes,
cancelled
sir.
up. So at the point of
Yes,
contact,
sir.
what is the
So,
velocity? 0.
0, sir.
So that is a
Yes,
condition
sir.
for your rolling of your body. So what is the condition for rolling without slipping beta? So condition for rolling without slipping is VCM must be equal to your R omega. VCM must be equal to your how much for me? R into your omega.
R
Is it
omega.
clear?
Yes, sir.
Next one. Now see, the velocity of a point on the wheel is a vector sum of two velocities beta. ఒకటేమో VCM, ఇంకోటేమో velocity due to your pure rotation. అంతే కదా? 2. The
Yes,
velocity
sir.
of a point on the wheel is a vector sum of two velocities. ఏమేమి velocities ఉన్నాయి right now? Velocity because of pure translatory and velocity because of your pure rotatory. అవునా కదా? So velocity of a
Yes, sir.
point on the wheel is a vector sum of two velocities, that is VCM, and velocity due to the pure rotation. Now velocity at point A, if I'm writing, say it at highest position, because of first one translatory VCM in the front direction, because of rotation R omega in the front direction. So velocity of B ఎంత వచ్చిందన్న VCM plus R omega వచ్చిందా?
Yes, sir.
అవునా కదా? For pure rolling we know
Yes,
that
sir.
R omega is how much? VCM only na. So at highest position how much is the velocity na? 2 times of your VCM. The point clear? This is because of translatory motion. This is
Yes,
because
sir.
of rotatory motion at highest
Rotatory.
position.
Yes, sir.
At highest position. At highest position. This one. This two I'm adding. Velocity of the B of rolling motion enta ante VCM plus R omega rastava. So we'll be writing VCM plus R omega at a point of B. Isn't it?
Yes, sir.
Got it? Or are you getting any difference?
Yes, sir. Yes, sir. Understood, sir.
Okay. Now in the same way, velocity at point C. Velocity at point C means here. For this one, VCM is in the front direction. For this one, R omega is in the upward direction. Add both of the vectors. I'm adding like this
Perpendicular
one.
that.
Because of translatory in this direction, because of rotatory in this direction. If I add these two
Yes, sir.
vectors, we are getting VCM and R omega. This is the velocity of C. So direction of this one is in this direction. So that is the reason we are getting this angle theta. Like see, if you might have been seen anytime washing of your car, maybe washing of your two-wheeler, when you keep the water on the backside of a tire and rotate it, the water will be moving in the tangent, but not in a straight line. Like say when a car
Yes,
is
sir.
moving
Yes.
in your what you call the watery part also, so the moment it touches the water, what is happening, water will try to rise in this direction or maybe an upward direction, but not in the front direction, exactly front
Yes,
direction lo
sir.
both. So here if I'm taking the combination of both of them, VCM and R omega, velocity at the point of your C on the wheel is directed in this direction. That is the reason the wheel is moving in the front direction, because this VC is moving, pulling that car, what you call the wheel in the front direction. So this is vector kabatti VC is equals to under root of your VCM square plus R omega whole square. వచ్చింది కదా? ఎలా వచ్చింది ఐడియా ఉంది
Yes,
కదా?
sir.
So as
Yes,
VCM
sir.
is R omega, so VC will be equal to how much for me? Root 2 into your VCM. Okay na?
Yes, sir.
Now tan theta is how much better? Tan theta is equals to R omega by VCM. Tan theta is
Yes,
equals
sir.
to
In
R
which
omega by VCM. R omega is already
and
VCM
R
kabatti
omega is
VCM
equals
VCM
to
get cancelled,
VCM.
that is one. So theta will be equal to 45 degrees.
45. Yes, sir.
Clear? Now in the
Yes, sir.
same way, velocity at point D, if I'm taking it. Velocity at your point D. Where is the point D? Where is the point D? This one. This is a point D and this is a point D. So for this one,
Yes,
point
sir.
D velocity is in this direction. For rotatory motion, R omega is in the downward
Downward.
direction. So just see in the diagram. See, VCM in the front direction because of translatory motion, and this is because of the rotatory motion in the downward direction. You add these two vectors. So this is VCM, this is your R omega. So this is the resultant velocity. That is nothing but of your VD. And this is also making an angle how much? 45, because R omega is also equal to your VCM only na. R omega is
Yes, sir.
again equal to your VCM. If this one and this one are two sides are equal, then angle will be obviously how much for me? 45 degrees only na. So velocity at D is equals to under root of your VCM whole square plus minus of your R omega whole square. And this minus J cap on the other. This one is your in minus J
Yes,
cap.
sir.
This one is your plus of your I cap. In this one minus, if
Plus
you take, then it
5
become
cap.
plus only. So velocity at point D will be equal to root 2 into your VCM.
Root 2. Yes, sir.
Clear?
Yes, sir.
Now at point A, where is your point A, beta? Can you see? Where is your point A? This one. So for point A,
Downward.
for pure translatory motion, front direction. For pure rotatory motion in the backward direction. So if I
Backward
add
direction.
both of them, so that will be getting here at this point like VCM and R omega. So let me write out like that right now. So velocity at your point A is equals to your how much? Now see the vector right now here. Because of the translatory motion, it is in the front direction. Because of the rotatory motion, R omega is in the backward direction. So the resultant will be VCM, and this one R omega is also VCM only na beta. So both of them are equal and opposite kabatti ఎంత అవుతుంది? If this is plus 2 and this is minus 2, so resultant will become how much? At the point A, the velocity will be equal to how much beta? 0. Is it clear?
Yes, sir.
Is it clear? So we got an idea how to
Yes,
calculate
sir.
the velocity at the different points na beta. Is there any condition right now?
Yes, sir.
So what is the condition for your pure rotatory, pure rolling motion beta? Condition for the pure rolling is at the point of contact, whenever it is in the on the ground, the velocity of VCM must be equal to R omega. This is your condition for your rolling. Condition for rolling without slipping. Condition for rolling without slipping. Is that point clear?
Yes, sir.
Chalo. Now see in this one, what I have written is the motion of the pure rolling, that is rolling without slipping, can be assumed as motion of what? Pure rotation about the point at the instant under the consideration that axis passing through that point, contact point, is called as of what? Instantaneous axis of rotation. అంటే ఈ పాయింట్ ఏది ఉంటుందో డ్యూరింగ్ ద రొటేటరీ మోషన్ పార్టికులేషన్, ఈ పాయింట్ ఏది తీసుకున్నామో ఈ పాయింట్ ఏ, when the particles are rotating, it is in contact with the ground kada. So point C,
Yes, sir.
the axis will be your A. For point D, the axis will be your A. Ante kada, because it is rotating about this point on the ground. Ona kada. This is the center of mass, moment of inertia center of mass, and this is your axis on which the total wheel is rotating. It is not rotating at the center
Yes, sir.
kada. It is rotating about this point. Ante point A is common for C, point A is common for D, point A is common for your B. So the point where the particle is moving in the circular path and if point A is common for all of them, that point is called as of your point of contact, or another name for that one is instantaneous axis of rotation.
Instantaneous axis of
Axis
rotation.
passing through the contact point. The axis passing through
Yes,
what?
sir.
The
Like A.
contact point is called as of your instantaneous axis of rotation. So let me say you right now here. See, if this is a point, this is a point of contact kada. So this is a point C, this is point D. When it is point C, root 2 r omega in this direction, we got just now the value. For point D, it is in this direction. అవునా కదా, డైరెక్షన్స్ వచ్చాయా లేదా చూడు ఇంతకు ముందు.
Yes, sir.
So for this one in the front direction, and for the point D, in which direction we got right now? See, for point D, we got in this direction. So the two directions combined just come. So point C, the velocity is in this direction. Point D in this one. So for point C and point D, point A is the instantaneous axis of rotation because it is rotating about this point covered. Okay, na? Now see,
Yes,
this
sir.
velocity root 2 r omega is perpendicular to this radius. Here also root 2 r omega is perpendicular to radius. That means in any
Yes,
rigid
sir.
body beta, if any rigid body, we have got two velocities like this. Like say if this is v1 and this is v2. Drop a perpendicular from there in this direction. And from v2 drop a perpendicular. The point where the two perpendiculars are meeting, that point is called as instantaneous axis of rotation.
Axis of rotation. Okay, sir.
Is it clear? Isn't it?
Yes, sir.
So this is totally a rigid body beta. This is totally a rigid body. This is totally a rigid body particulation where we are having n number of your particles, isn't it? So like that, if you are taking any particles of your velocities in this one right now, if you draw a perpendicular to that one, if you draw a perpendicular to that one right now, and if the two perpendiculars wherever are the meeting, that point is called as instantaneous axis of rotation. Like see, if this is the velocity for this one, you make one axis like this. If this is a velocity, you make one axis, and the both of them are meeting somewhere at this point. This point is known as of your instantaneous axis of rotation. So what is mean by instantaneous
Yes, sir.
axis of rotation? The axis passing through the contact
Contact
point
point.
is called as of your
Yes, sir.
instantaneous axis of rotation. Is it clear?
Yes,
If
sir.
your particle is moving in this direction, drop a perpendicular from that one. This will be your instantaneous axis of rotation. Okay, at the point of contact. This is VCM gada.
Yes, sir.
So point of contact, you draw a perpendicular. So that will give you the instantaneous axis of rotation. Okay, now.
Yes, sir.
Sure. Next, this is also instantaneous axis of rotation. Every point is doing the circular motion about some point. This has been taken by some camera. You are seeing that as if this keyboard is moving in a circular path. Are you able to see the
Yes,
shape?
sir.
Isn't it? Now,
Yes,
even
sir.
in this is the instantaneous axis of rotation. At this point, if I take one point here, the velocity is in this direction, perpendicular. If I take here, it is making an angle. Or else like this point, this point, this point, this point, any point you take, if from the point of contact, it is exactly perpendicular. So that point which is in contact with the ground and perpendicular to the velocity is called as what? Instantaneous axis of rotation. And for pure rolling, this V will be equal to how much beta? Omega bar cross R bar. Okay, now.
Yes, sir.
Okay, so that is the points you need to remember. Now see, pure rolling motion, what I told you, it is a combination of pure rotatory and pure translatory motion. Are you able to see
Translate.
this one beta? Pure rotation, pure translatory motion. ఈ రెండింటిని యాడ్ చేస్తే we are getting what? Rolling motion. Now for pure rotation, here it is VCM front direction opposite. Whereas for the pure translatory motion, each and every particle is moving in the front direction. So if I add it at the highest position, we'll be getting 2 times of your VCM. and at the lowest position we are getting minus VCM plus VCM, that is equals to how much for me? 0.
0.
For sleeping, the condition is what I told you, V is equals to R omega. V is
Omega.
equals to R omega. Cycloid trajectory and it ఉంటుంది, isn't it? If you might have been seeing the spin of the ball in the 3D participation, so you might be seeing this is as if you're not making complete circle. So this is a part of a
Yes,
circle.
sir.
If the motion is continuously like that, such type of a motion is called as of what? Cycloid trajectory. Is called as of what? Cycloid trajectory
Cycloid trajectory.
participation. Clear? Chalo.
Yes, sir.
What are the condition for rolling without slipping? So whenever you're doing the problems rolling without your slipping, keep this point into the mind. The first one, the contact of the body with the surface is always assumed to be what? One single point, like the wheel. The wheel of your car is in contact with the ground every how many points? Only 1 point, gada.
1. Yes, sir.
The
Like
same way,
A in
relative
that.
velocity, yeah, relative velocity at the point of contact must be equal to how much?
0.
0. అవునా కదా? And energy is conserved in this
Yes,
one.
sir.
Energy is conserved. Initial energy will be equal to final energy. Initial energy will be equal to your final energy. Is it clear?
Yes, sir.
Isn't it? So what are the conditions for rolling without slipping beta? The contact of the body with the surface is assumed as a single point. Relative velocity at the point of contact is 0 and energy is conserved. And energy is conserved. Is it clear?
Sir. Yes, sir.
Sure. Next one, beta. Now see, for solid sphere, if I'm talking about for a rolling motion, what are the motion energies we are having beta? Okademo translatory motion. Translatory motion is how much? Half into m into VCM square. And rotatory motion is how much beta? Half into ICM into omega square. Isn't it?
Yes, sir.
Isn't it? And for pure rolling, what is the condition? VCM must be equal to what? Rolling and
R
pure
omega.
rotatory. So it is a pure
Yes, sir.
rolling motion. It is a pure rolling motion. So what is a rolling? Rolling is a combination of translatory motion plus
Translate and rotation.
rotatory motion, pure rotatory motion. So for pure rolling
Yes, sir.
motion, VCM must be equal to R omega. And you also know that moment of inertia in terms of radius of gyration, ICM is equals to m into k square. Gurtunda?
Yes, sir.
Like say if
When we
I'm
did
having
radius.
rigid body and if it is having some millions of particles and this is the axis, how many distances will be writing? R1, R2, R3, R4, R5, R6, R7, R8, R9, R10, like so in order to overcome this one,
Yes, sir.
what we are doing is we are assuming one center of mass, as if we are assuming the total body's mass is concentrated at the center of mass, and we are drawing one perpendicular distance from this one. This perpendicular distance is represented by letter K. This K is known as the radius of gyration. So ICM is equal to how much for me? M into K into your R square. Sorry, K square. Okay, na?
Yes, sir.
Like say for rigid body, instead of writing R1, R2, R3, what I'm doing is I'm removing all that R's. I'm representing by one common distance. That common distance is represented by letter K. That K is called as of what? Radius of gyration.
Gyration.
చెప్పాను కదా, ఇది గుర్తుంది కదా?
Yes, sir. Yes, sir.
Okay, chalo. Now for the pure rolling, we are having translatory and rotatory. So rotatory can still be written as half into ICM will be equal to what beta? M into K square and raskona. And omega will be equal to,
Yes, sir.
from this one, omega VCM by R. So it is VCM by R whole square. Okay. And this one K square
Yes,
and
sir.
this one is R square. You bring it out. So it is K square by R square into, this is half, this is M into VCM square. Half into M into your VCM square. Isn't it? So this is exactly similar to what beta? Translatory kada?
Yes, sir.
Isn't it? That means I can write this one as of your K square divided by your R square into your KT and raskocha.
Yes, sir.
Isn't it? Now total kinetic energy ఎంత అవుతుంది? Total kinetic energy of your rolling motion. Total kinetic energy of your rolling motion. Kinetic energy of rolling motion is what? It is the combination of translatory and rotatory. It is
Rotation.
the kinetic energy of the translatory motion plus kinetic energy of the rotatory
Continue
motion.
to rotate.
Translation motion is how much per me? Half into M into your VCM square.
V
And
square.
rotatory
Yes, sir.
motion is how much per me? This one I got here. K square divided by
Sir.
R square into
R
half
square.
into M into your VCM square.
MV. Yes, sir.
Now half VCM square I
Yes,
can
sir.
take common. So it will be 1 plus K square by R square. That means for a pure rolling, the total kinetic energy is represented by the formula half into M into your VCM square into 1 plus K square by R square. Is it clear?
Yes, sir.
No doubt on that. Combination of translatory and rotatory is total kinetic energy of rolling body beta. So translation kinetic energy is half
Yes, sir.
into m into VCM square, and rotatory motion is k square by r square into half into m into VCM square. Half m VCM square, half
Sir,
m VCM square
normally,
common. Huh.
sir, normally for rotatory motion, we'll get half into I omega, no, sir.
అది కదా రాసింది నేను ఇక్కడ. In general, it is
Yes, sir.
half into ICM into omega square. You can even
Omega
just
square.
add
Yes,
it
sir.
if you know the moment of inertia of that bodies.
Okay,
Okay.
sir.
In the pure rolling,
If
what
it's
we are
unknown,
taking
then we have to
ICM.
use.
Yeah, I'm just
Yes,
using
sir.
IC means m into k square. లేదనుకుంటే you can
Yes, sir.
directly write like this only. That is not a problem. Like, see, you can
Okay, sir.
even write like this itself also if you are confusing with that one. So I can write here that point C. A total will be equal to kinetic energy because of this is total. This will be translatory motion plus kinetic energy due to the rotatory motion. Kinetic energy due to translatory motion at a half into m into your VCM square, plus this one will be equal to half into m into your, sorry, half into your ICM into your r square. So omega square.
Yes, sir.
This one is omega square. Yes, sir. So in this one, if I'm taking half m VCM square common, that means omega I can write as what beta? So this one is your half into m into your VCM square plus half into your ICM into your omega is equals to how much for me? VCM square divided by r square. V is equals to r omega. So omega is equals to how
Yes,
much
sir.
for me? This one I can write. Now what I can
Yes,
take
sir.
common. If I take half into m into your VCM square common, this will become for me 1 plus of your, this will become for me moment of inertia ICM divided by m into your r square. Can I write like this?
Yes,
I
sir.
divide multiplied by your m, because if I take same small m
Yes,
only,
sir.
this one. This is a small m only.
Okay.
Listen, if I multiply this one, I'll get this one. If I multiply this one, gets cancelled, again I'll be getting this one. So
Yes,
you
sir.
can even the total kinetic energy like this. There is no problem. Provided if you just know the moment of inertia of that body, you write that moment of inertia here and simplify it. You'll get the answer. Okay. Like
Yes,
if
sir.
it is solid sphere which is rolling. For solid sphere, what is the moment of inertia beta? I is equals to 2 by 5 mr square. అంతే కదా.
Yes, sir.
So now if I'm writing the kinetic energy, total kinetic energy will be equal to how much for me? Half into m into your VCM square into 1 plus this one is a 2 by 5 m into
2
your
by
r
5.
divided by your
R.
m into your r square, mr square gets cancelled. 1 plus 2 by 5 is 7 by 5. So this will become for me 7 and 5 into 2 10. So this will be equal to 7 by 10 into m into your VCM square. What's
Yes, sir.
1 plus 2 by 5 is 7 by 5 beta. So
Yes, sir.
7 by 5 into 1 by 2.
7.
So it is 7 by 10. And half 7 by 10 is
Yes,
m
sir.
into VCM square. Okay. So you can even write like
Yes,
this.
sir.
There is no problem. Okay. So I'm
Okay.
just to make a simplified way, I have written that condition there. See what I have done here is right now. In the place of ICM, I have written as of your m into k square. And in the place of omega, I have written VCM into r. So I got rotation as of your k square r square into half into m into your VCM square. Now total kinetic energy
Yes, sir.
means it is because of the translator and kinetic energy. Add them. So we are getting one formula half VCM square common into 1 plus k square by r square. Now for solid sphere, you see, for solid sphere, moment of inertia is how much beta? 2 by 5 mr square. Kada? So
Yes,
I
sir.
value is how much? M into k square. So this m gets cancelled. So k square, this r square if I get, so I got this value with k square by r square is 2 by 5.
Yes, sir.
So 1 plus 2 by 5 is how much? 7 by 5. You get the answer. The same way for hollow
Okay.
sphere.
Yes, sir.
For hollow sphere, the moment of inertia is how
2
much? 2
by
by
3
3
MR
mr
square.
square. I value is how
Yes,
much?
sir.
M into k square. So m and m if I get cancelled, so k square by r square value is 2 by 3.
2 by 3.
Okay now. Same way
Yes, sir.
for the solid cylinder or disk. Moment of inertia is mr square by 2. I value is how much? M into k square. This m gets cancelled. So k square by r square is how much for me? 1 by 2.
Yes,
Oh,
sir.
no? No. That means the total energy I can write as what beta? Et into 1 plus k square by r square, or E is equals to ER into 1 plus k square by r square. Translation and rotation. Just reverse chesedinki will be getting in terms of translation, in terms of rotation. Okay. So E is your total energy.
Yes, sir.
T is your translational kinetic energy and ER is your rotational kinetic energy. ET by E అన్నాడు అనుకోండి, ET by your E. So that will become for me how much? 1 plus k square by r square to the power of -1. అంతే కదా, ఇది కిందికి
Yes, sir.
వెళ్ళిపోతుంది,
Yes.
ఇది కొంచెం పైకి
Yes.
వెళ్ళిపోతుంది. So that is known as what? Ratio of translational kinetic energy to the total kinetic energy. If he is asking, the ratio of translational kinetic energy to the total kinetic energy, then it is ET by E. Now, if I am asking the ratio of rotational kinetic energy to total energy, that means ER by E. That will be equal to 1 plus r square by k square to the power of -1.
Yes, sir.
Okay, from this one only. ER by ET తీసుకోండి, ఇది కిందికి వచ్చేస్తుంది, పైకి
Yes,
వెళ్ళిపోతే.
sir.
Okay, if you can just remember this one basic formula, you can write anything. It
Yes,
is
sir.
asking the ratio of translation by total energy anko, ER by ET. If it's asking the ratio of your what do you call that one, translation by kinetic, rotational by total energy ante 1 plus of your r square by k square to the power of -1. Okay na?
Yes, sir.
So these are the two formulas which you need to just remember it while doing the numericals. By little bit practice, you can remember this one basically. Okay na? So that was about your
Yes, sir.
pure rolling motion. I hope you got a conditions for a pure rolling beta. So whenever you're doing the problems related to pure rolling, make sure that the contact point should always have only one single point, and relative velocity at the point of contact should be equal to 0, and energy is conserved. Is it clear?
Yes, sir.
Sure. See this one example. A solid sphere of mass m rolls without slipping on the ground such that VCM is V0. So what is the total kinetic energy? So what is the total kinetic energy formula? Half into m into VCM square plus 1 plus k square by r square. It is moving with VCM and also rotating with omega. VCM is how much? V0. So it is half into m. VCM I am writing as V0 square into 1 plus k square by r square. How much we got for solid sphere? 2 by 5.
2 by. Yes.
So 1 plus 2 by 5 is how much? 7 by 5. So 5 into 10. So total kinetic energy is 7
Yes.
into mv0
7.
square divided by 10.
10.
ఒకవేళ హాలో
Yes.
స్పియర్ తీసుకుంటే ఇక్కడ ఏమైతుంది? 2 by 3 వస్తుంది.
2 by 3. Yes, sir.
Isn't it? Like that we can go on write the values. Okay
Yes,
na?
sir. Yes, sir.
Sure. See this one problem beta. We have got an halo sphere which rolls without slipping. So what it is doing? It is rolling. So whenever it is rolling means what it has beta? It has translatory, that is V, and also rotatory, omega. Isn't it? So body is moving
Yes,
in the
sir.
front direction also. So it is having the linear velocity and is also rotating. So it is also having the angular velocity. So halo sphere rolls without slipping on an horizontal surface such that its translational velocity is given as V. Now find that the maximum height attained by it on the inclined surface is how much? Find that the maximum height attained by it on the inclined surface is equals to how much? Like see, from this horizontal surface, the body is moving like this and rises to certain height. Isn't it? So from here it is going
Yes,
like
sir.
this and goes to a certain height. So this is your reference beta. At reference, the potential energy is how much? 0. When you go from certain height to the ground, it has what energy? Potential energy. Now see here, when the body is rolling
Yes,
at
sir.
point A, it is having translatory power and rotatory power. అంతే కదా, ఇది rotate కూడా అవుతుంది, ముందు కూడా పోతుంది. అవునా కదా?
Yes, sir.
Now when it is going like this, a point will come at highest position where it will stop. When it is stopping means that is the maximum height which has been reached from the ground కదా, అంతే కదా?
Yes, sir.
నువ్వు ఇక్కడ నుంచి ఒక బాల్ వేసావు అనుకో, రోలింగ్ బాల్, ఈ బాల్ రోల్ అవ్వకుండా ఈ ఇంక్లైన్ సర్ఫేస్ పైన
Good
కొంచెం పైకి
to
వరకు వెళ్ళి ఒక సెకండ్ ఆగి మళ్ళీ
yeah,
కిందికి
can
వచ్చేస్తుంది.
come. Yes,
ఓకే,
sir.
సో ద మొమెంట్ ఇట్ ఈస్ స్టాపింగ్ ఫర్ దట్ ఫ్రాక్షన్ ఆఫ్ సెకండ్, దాని యాంగులర్ వెలాసిటీ ఎంత అయిపోతుంది? 0 అయిపోతుంది కదా, రొటేషన్ కూడా
0.
స్టాప్
Yes,
అయిపోతుంది,
sir.
అండ్ ఫైనల్ వెలాసిటీ
Yes,
ఇస్ ఆల్సో
sir.
బికమింగ్ 0. బిఫోర్ ఇట్ డ్రాప్, ఇట్
0.
మైట్ హావ్ బీన్ రైజ్డ్ ఫ్రమ్ ది గ్రౌండ్ ఏ హైట్ కదా, మాక్సిమం హైట్. దట్ హైట్ ఐ యామ్ టేకింగ్ ఇట్ యాజ్
Yes,
ఆఫ్
sir.
యువర్ హెడ్. Okay, so now in case of pure rolling, energy is conserved kabatti, and for no slipping, what is the condition? V is equals to r omega. That things you need to keep in the mind. So applying the energy conservation at point 1 and point 2, at this 2 point I am applying the energy conservation. So initial kinetic energy plus initial potential energy must be equal to final kinetic energy plus final potential energy. That means this is half into m VCM square plus half into ICM into your omega square, isn't it? So that will be equal to how much for me?
Yes, sir.
mg into your h. ఎందుకని ఫైనల్ కైనెటిక్ ఎనర్జీ 0 కదా, ఫైనల్ వెలాసిటీ 0, v2 is 0, V1 is your VCM. That is the reason V1 I am writing as VCM. Initial potential energy, because this is both rotation kinetic energy kada, rolling. K1
Yes, sir.
ante. K1 it is because of both rolling and the rotating kada. Isn't it? So
Yes,
that is
sir.
the reason I have
Because
written
it's
translatory and
pure rotation.
rotatory. Initial potential energy will
Yes,
be
sir.
0. Kinetic energy will be 0. Potential energy of the system will be mg into h. Isn't it? Now you know what type of a body it is rolling better. What type of a rolling body is rolling? Halosphere. Now for halosphere, you know the moment of inertia?
2 by 3.
2 by 3. So that value I have written half into m. VCM is V plus half. ICM is 2 by 3 m into r square into omega square is how much for me? V square by r square. That is equals to mg into h. This mass gets cancelled. So this one is V square by
Yes,
2
sir.
plus V square. This one is how much for me? This two also get cancelled. This r and this r square will also gets cancelled. So it is V square by
Yes, sir.
3 is equals to g into your h. Antena? So now
Yes,
v
sir.
square by 2 plus v square by 2, if I am simplifying it, is 5 by 6 into v square. So 5 by
V
6
square.
into v
Yes,
square
sir.
is g into h. So h is equals to 5 into v square
5 is
divided by 6 into g.
6G.
Okay,
Yes,
na?
sir. Yes, sir.
So I hope you got an idea related to this one. So this is the way you need to do the rolling motion introductory part of relation. We'll try to go for the applications of this one in the tomorrow session of a class. I given one problem here, beta. You try to do it out. Very good question. అర్థమైతే మంచిది. Otherwise, I'll try to help you out in the tomorrow session of your class. Time ఉందా మన దగ్గర
Okay, sir.
ఇంకా?
ఎస్ సార్. అంటే ఈరోజు
Body
కూడా ఏం
time.
రాలేదు సార్ ఆ మెసేజ్.
Okay. అయితే ఇది చెప్పేస్తాను. రఫ్గా టైం ఉంది కదా.
ఓకే
Okay,
సార్.
I hope you got this idea how to do such type of a problems. Then ఇంకా
ఎస్ సార్.
problems
ఎస్ సార్.
చేపిస్తాను
గాట్
చాలా.
దిస్ సార్.
So you can just take it out. Now see this question, but it's a really very beautiful question. We got a disk which is rolling without slipping on an horizontal surface, beta. What we got? We got a disk which has been rolling without slipping on an horizontal surface such that its velocity of center of mass is v. Find the velocity of the points A, B, and C. Like this. This is a point A, this is point B, this is point C, and this is point D. So point A is at a distance of R. Point B is at a distance of R, but making an angle 60
ఆర్.
degrees. Point C is a distance of R by 2.
ఆర్
And
బై
point
2.
D is a distance of R by 3.
ఎస్ సార్.
Okay, see the question. What is rolling now? Disk. You know for the disk, what is the moment of inertia? Mr square by 2.
ఎస్ సార్.
Disk and solid cylinder is same. Kada.
ఎస్ సార్.
So what is the rolling means what? Rolling means what? Without slipping. What is the condition for the body rolling without slipping? VCM must be equal to R omega.
ఎస్ సార్.
Isn't it? And in rolling, what we are having better? Translatory and
ట్రాన్స్లేషనల్ అండ్ రొటేషన్.
rotating. Now let us try to see for point A. So rolling is what? Translatory plus kinetic. Antena? Because of the rotation,
ఎస్
both the
సార్.
translatory and rotate. Now for point A, chudu. For point A, and the particle is rotating. Now it is totally okate danta draw chesana, two individual draw cheyaledu. That means you should
ఎస్
understand that
సార్.
at point A we are having VCM in the front direction, and point A R omega will be in this direction, beta. Upward direction only, na? Because it is moving in this direction. At this
ఎస్
point,
సార్.
have you got an idea? At this point, this will be
ఎస్
your
సార్. ఎస్
R
సార్.
omega.
గాట్ దట్ సార్.
And at this point also we'll be having R omega.
ఆర్ ఒమేగా. ఎస్ సార్.
At this point also we are having R omega like this.
ఎస్ సార్.
And at this point D also we are having R omega like this. R
ఎస్
by
సార్.
3 omega. This one is R by 2 omega. So R omega is how much for me? V. And this will become V by 2. And this will become for me how much? V by 3. Ante kada?
ఎస్ సార్.
Like say VCM is R omega kada. VCM is R into omega. How much I'm having right now here? This is R by 3 kada. So R omega is nothing but V by 3 I can write.
ఎస్ సార్.
Because R omega is nothing but V only. Na? That is the reason. Now for point A, tell me, see, for point A, VM in this direction, because see, center of mass is moving with velocity V. That means each and every
ఎస్ సార్.
particle of this one is moving with your V. This particle is also moving with your V. This particle is also moving with your V. Okay, na?
ఎస్ సార్.
So now point A, this is in this direction. Now point A, R omega in the upward direction. So if I add both of them, so this is your V and this is your R omega. R omega is also V. So velocity of your point A will become how much beta? Root 2 into your V. Tan theta will be equal to 45.
45. Yes,
వచ్చింది
sir.
అది. Now
Yes,
point
sir.
B కాడ చూడు, point B కాడ, isn't it? What is an angle between this one and this one, beta? This 60, yeah? Alternate angle, this one is also 60.
Yes, sir. That is 60, sir.
This total angle should be 90.
90. 30, sir.
So this angle is how much?
30.
30. So angle between V and R omega is how much for me? 30. So అదే రాశాను చూడు point B కి. See, for point B, V is in this direction and
Yes, sir.
R
30.
omega is in this direction. అంతేనా? ఈ రెండింటిని
Yes,
యాడ్
sir.
చేస్తే ఎట్లా వస్తుందా? So angle
Yes,
between
sir.
them is how much? 30 degrees. So two vectors are inclined at angle theta. So resultant will be parallel by the parallelogram, the
Yes, sir.
diagonal of that one. So velocity of
Yes,
B
sir.
is under root of V square plus V square plus 2V into V into cos 30. Cos 30 is root 3 by 2. V into V is V square. This V square common కాబట్టి బయట తీసుకొచ్చేసి this is 2 plus root 3 will be the velocity of B. వచ్చిందా?
Yes, sir. Yes, sir. Got it.
Okay. Now can you tell me what will be the velocity at point C? What will be the angle between the two vectors, beta? This is V and this is V by 2. So angle between these two vectors
90.
90 కదా? అంతేనా?
Yes, sir. Because perpendicular.
Both
Yes,
of
sir.
them are perpendicular part affiliation. Now see, I have drawn the diagram here. For point C, the point C is moving in this direction and R omega is in this direction. R omega is how much, beta? V kada? So it is V by 2. So one vector is in downward direction V by 2. One vector is in the positive direction V. So resultant will be equal to this one. This is nothing but of your VC.
Yes, sir.
V will be equal to under root of your V square plus V by 2 whole square. V square plus V by 2 whole square. That means velocity of
Yes,
your
sir.
point C will be equal to V square by this 1 plus 1 by 4. So how much it is? Root 5 by root 5 into V divided by 2.
2.
అంతేనా?
Yes, sir.
No, see. Next one. Point D. Sorry, point D la V ఏమో ఈ డైరెక్షన్ లో ఉంది అండ్ R omega by 3 డైరెక్షన్ లో ఉంది. ఇట్లా ఉంది ఇది. V ఏమో ఈ డైరెక్షన్ లో ఉంది. ఇదేమో ఈ డైరెక్షన్ లో ఉంది. This one is R by 3 into your omega. So what is the angle between them? Already this angle is how much right now? 90. అవునా కదా? So this angle is how much right
Yes,
now? ఈ
sir.
angle already problem length ఇచ్చాడు 60 degrees.
60.
Isn't it? So this angle will be equal to how much here? 30, 90 కదా? With respect to this radius vector. ఇది 90 యా?
Yes, sir.
This is 60, this is 90, this will become 30. So 90 plus 30,
Yes, sir.
how much?
120, sir.
120. So angle between them will be equal to 120. చూడు ఇక్కడ draw చేశాను.
120.
చూడు. This is in this direction. So it is going in this direction. And this is your 120 like this. Isn't it? Angle with respect
Yes,
to
sir.
this point is right now 120. So if I add this vector here right now, so angle between V and see this is R by 3 omega kabatti R omega is V. So this is V by 3. So angle between them is 120. You know cos 120 is how much, beta? Cos 120 is minus of 1 by 2.
Ah, yes, sir.
Avuna? So now I'm writing that one.
Yes,
So
sir.
velocity of D is under root of V square plus V by 3 whole square plus 2V into V by 3 into cos 120. Cos 120 is minus 1 by 2. So V square, you bring it out. So I'm bringing it out. So this will be V square plus V square by 3 square is 9. So this will be equal to 2 into V square divided by 3 into cos. This 2 will get cancelled. So it is V square plus V square by 9 minus V cube by your 3. So how much you are getting velocity at point D? So velocity at point D is under root of 7 into V divided by 3. So that will be the velocity at your point D. Okay, now
Yes, sir.
got it?
Yes, sir.
So I hope you got a clarity about the introduction of your rolling motion. This is just an introduction of rolling motion, beta. We have a lot to do in this one.
Okay.
So this is the only thing you need to remember. So just make sure that you write the notes of this one. If there are any doubts, you please let me know and help you out.
Okay, sir.
Chalo. Okay?
Yes, sir. Thank you, sir.
Okay, chalo. Bye, beta.
Bye, sir.